applications involving quadratic equations, the principle of zero products. What this means is that when you multiply two numbers together and it happens to equals to 0, then either one of those numbers have to be 0, and that is the zero product principle. So we use that in order to solve quadratic equations by factoring. Now recall what it means to solve a quadratic equation. To solve a quadratic equation means that you begin by setting the equation equals to 0. So set the equation equals to 0, and that means that you might have to maybe remove some numbers by adding or subtracting some values. And also, and then you're gonna factor, and that's part of the process of factoring to solve. So without further ado, let me take you through a few examples here on how to solve by factoring. So to solve, the first thing we do is we have to set it equal to 0, which means that we need to subtract 8 to both sides. That brings our equation to x squared minus 2x minus 8 equals to 0. So we turn it into an equation, and now we're going to solve this equation by factoring. So by factoring means that we draw an x box. Negative 8 and negative 2 will go into those respective area. And then we find two numbers whose product is negative 8, but whose sum is negative 2. And these are the two numbers that we are looking for. So once we have found those two numbers, then we can factor it into x minus 4 and x plus 2. And from here, then what we do is we apply the zero product property, because it says that if two numbers, think of it as one number, think of this as a second number, if two numbers multiply together to equal to 0, then that means that either one of those two numbers have to equal to 0. So we call this the first factor, and we call that the second factor. And we set each factor equals to 0, and then we solve. So by adding 4 to both sides, we know that one of the solution is x equals to 4. And by subtracting 2 to both sides, we know that another solution is x equals to 2. So here are the two solutions that satisfies this problem. We can also call these the x-intercepts, because those are what solutions mean. Solve. We begin the process by setting it equal to 0, so we'll need to subtract 10b to both sides. We end up with 5b squared minus 10b equals to 0. Because this quadratic equation is missing the constant term, we don't need to create an x box. To factor, we just look and see what they have in common. They have a 5b in common, so we pull that out. So therefore now we have the product of two numbers. You take each number and you set it equal to 0. Okay, take each number and set it equal to 0. That means that b equals to 0 and b equals to 2. Find x such that f of x equals to 1. What this means is find x so that the output is 1, because f is the name of the function, which also represents the output. Okay. So we go over here and we replace the f function by 1. So replace this with 1. This now becomes a quadratic equation, and in order to solve, to find x means to solve, we have to set it equal to 0. So then we subtract 1 on both sides so that we can get it equal to 0. Plus 25. Okay. Because this is a quadratic trinomial, we will factor to solve. the two numbers will go up here and there. And we're looking for two numbers whose product is 25. But when you add them together, you get 10. Once you have found those two numbers, then you will write them in here. So x plus 5, x plus 5. Therefore, now you have two factors, and because these two factors are identical, you just need to solve for one of them. So guess what? X equals to negative 5 is our only solution to this problem. Applications of quadratics. We will now apply the techniques we learned on how to solve quadratic equations to solve problems that involve a quadratic function. Let's take a look at the problem in question here. The dimension of a rectangular flower garden were 8 by 15. Each dimension was increased by the same amount. The garden then had an area of 198 meters squared. Find the dimension of the new garden. We begin this problem by drawing some diagrams to help us solve the problem. This is the original dimension of the rectangular garden. However, it got stretched by the same amount. And the area after being stretched is 198. So we use this information to try to find the dimension of the new garden. To do so, we find a relationship between the area and the length and the width. So area equals to length times the width. We now distribute 15 to 8. That brings us to 120. 15 times x, and also x times 8, and then x times x. To solve the equation, we set it equal to 0 by subtracting 198 to both sides. That brings us to negative 78. Also, we combine the two middle terms, and then the x squared. Last, we write it so that the leading term is the x squared. It now becomes a quadratic equation. So then to find the answer to what we're looking for, we will need to factor the quadratic equation. Negative 78 and also 23. A bit of searching will show up that the number 26 times negative 3 is negative 78, but when added together is 23. So now we can factor the problem as x plus 26, x minus 3. And using the zero product property, we know that one of the solutions is negative 26 and the other solution is positive 3. Now x represents a small increment in the new dimension of your rectangle. So you can't be adding a negative number. It doesn't make sense. Throw that away. And we conclude that the dimension of the new garden must be 18 by 11. 15 plus 3 is 18. 8 plus 3 is 11. More application of quadratics. However, this time it involves motion problem and free falling. An athlete's hang time is the amount of time that the athlete can remain airborne when jumping. And that's modeled by this function. V stands for the vertical leap, and T stands for the time that the athlete is in the air. They want us to solve this equation for T. So to solve for T, we basically isolate T. So go over here and write down the original problem and begin by dividing both sides by 48. This allows us to isolate T squared. And then to isolate t, we use the square root technique. So we take the square root of both sides, like this. And that should allow us to isolate t. So therefore, t equals to the square root of v over 48. Let's take a look at another problem involving motion or free falling. A tennis ball is thrown downward from a 120 feet high bridge to a stream below. How long does it take the ball to fall 24 feet if the initial velocity is 2.2 feet per second? So you got a bridge. And a ball is being thrown from the bridge into the stream. How long does it take the ball to fall 24 feet? Remember that the distance from the bridge to the stream is 120 feet. So S stands for our distance. So S equals to distance. T equals to the time. And V, this is the initial velocity. How fast does the ball travel initially? So if we know any of these two information, then we can find the third information. In our case, we know that the time, in our case, we know that the distance that we want it to fall is 24 feet. We also know the velocity, which is initially how fast it's falling. And we're asked to find the time. So then we take these two information that we know in the problem and we plug it in here. So we go S. So S is 24 because we want to know how long it takes to turn 24. 4.9 t squared is what we're looking for, so we don't know what t is. Velocity, v naught, is the initial velocity, and that's 2.2 t. Okay? And so we have everything we need. We're going to go ahead and solve this problem by setting it equal to 0. Okay? That becomes 4.9 t squared plus 2.2 t minus 24. All right? And then when dealing with a decimal, if we multiply both sides by 10, then we're able to get rid of all the decimals. So multiply both sides by 10. That brings us to something more manageable, right? So as you can see, this problem requires that we use a calculator to solve. So, or you can solve using many different methods. One of those methods is the quadratic formula. And that's the one that we're going to use for this particular problem. So A equals to 49, B equals to 22, and C equals to negative 240. Okay. Plug that into the quadratic formula. Negative B plus minus the square root of B squared minus 4AC, all divided by 2A. Okay? So let's plug that into a calculator and see what we come up with. So negative 22 plus or minus. For now, I'm just going to plus for now. And then we're going to go the square root of 22 squared plus, this is going to be a plus 4 times 49 times 240. Okay. And then we're going to take that and we're going to divide it by 98, because that's 98. And that comes out to be 2. So x equals to 2. X is really time, so time equals to 2. On the other hand, we're going to subtract now because there's a plus and there's a minus. So minus the square root of 22 squared plus 4 times 49 times 240 divided by 98. And that comes out to be -2. Now, time can't be a negative number, so we will not keep that value. We're just going to keep this value. So how long does it take for the tennis ball to fall 24 feet? The answer to that question is